All right, so we said there was two possibilities for C, and there were two possibilities for B, so I'll write them the same way. B1 is about 46.9, and B2 is about 133.1, 33.1 degrees. And notice if you add these two right with the 40, that'll be 180, and if you add these two with the 40, that'll be 180. So for sure, angle A is 40. They gave us that one, right? And then we found that that the other two, that there were two possibilities. Okay. All right. So if we have C1 and B1, then we also have side C will be different, right? So we have side B and side A given. So to find side C, let's call it C1, right? Lowercase c1. Okay. So to find lowercase c1, I know that A over sine of A, right? Side A over sine of, you know what? I should just write the numbers. So A is 22, and sine of angle A is 40 degrees. Should equal C1 over sine of C1, and C1 is 93.1 degrees. So sine of 93.1 degrees. And notice I'll be able to solve for side C1. Okay, so side C1 will be approximately, it will be, 22 over sine of 40 degrees times the sine of 93.1 degrees. And that'll be approximately 34.1, 0.2, let's say 0.2 according to my calculator. And then same thing with C2, right? So for C2, let's make some room here. So for C2, I have 22 over sine 40 degrees is C2 over sine of angle C2, which is 6.9 degrees. So I'll have side C sub 2 is 22 over sine of 40 degrees times the sine of 6.9 degrees. All right, and that'll be approximately 4.1. All right, so notice it's either side angle B is 46.9. I'm going to write 46.9. And C is 93.1. That's one combination. And then side C would be, what do we find? C sub 1 is about 34.2. And C sub 2 is about 4.1. So if I fill that in, the first one was 34.2. Okay. Notice the biggest angle is opposite the longest side, right? And the smallest angle is opposite the smallest side. And if I fill in the other possibilities, so the other possibilities were C2 was 6.9, B2 was 133.1, and then C sub 2 would be 4.1. And you'll notice the biggest angle opposite the biggest side, smallest angle opposite the smallest, shortest side. Okay, so that verifies that we're okay. All right, let's look at the next part here, part 3, computing the area of the triangle given a side and angle and a side. Remember how we looked at when we were trying to prove the law of sines, that we said same triangle, and we said sine of angle A equals h over b. So h equals b times the sine of angle A, or h equals side A times the sine of angle B. All right, and then notice the base of this triangle is C. And remember, the area is 1/2 the base times the height. So we could say it's 1/2 side C, right? What's the, that's the base, times the height. So it could either be B sine A, okay? So it would be 1/2 C times B sine A, or times a sine b, so it would be 1/2 c times a sine b. And if we had the other one, it'd be, we could also write it as 1/2 a times b sine c. All right, so notice where these are, right? So side B and C, let's say, and angle A. So we're talking about two sides and the included angle. Okay, so it's 1/2 the product of the two sides times the sine of the included angle. Okay, so we look at the example. A triangle has sides of 12 meters and 6 meters, and the angle between them is 76 degrees. I think we'll leave that one for class. I'm gonna leave that one for class. We'll draw the triangle in class, and then we'll work it out. Okay, let's do one more on the last page. These two are very similar, so we'll do letter A. It says to measure the maximum height of the water in a fountain, Jesse measures the angle of elevation of the maximum point to be 25 degrees. At a point 30 feet farther away along the same line of sight, the angle of elevation is 18 degrees. If the eye level of Jesse is 5.5 feet, that means his eyes are 5.5 feet off the ground, find the maximum height of the water to the nearest tenth of a foot. All right, so Jesse measures the angle of elevation of the maximum point to be 25. Okay, so he's at some point and he's going to walk farther away. So he's some distance from the fountain. Here's the fountain. Okay, and from that point, the angle of elevation is 25 degrees. I don't know the distance. And then he walks a little farther away along the same line. And then, and it's 30 feet farther away. So this is 30 feet from there to there. All right, farther. All right, so he's X, let's say X feet from the fountain, and then and that's 25 degrees angle of elevation, and then 30 more feet. And then from there, the angle of elevation is 18 degrees. All right, is that all we know, pretty much? Okay, so we want to know what the height is, and then remember we need to add 5.5 to know the total height of the fountain, 5.5 feet. All right, so we'll call the height from 5 feet up h, and then we'll figure out what is h plus 5.5. All right, so notice that we can write a couple of statements. We can say the tangent of 25 degrees is h over x. And we can write the tangent of 18 degrees is h over 30 plus x, or x plus 30. H over, I'll say x plus 30. Okay, we solve both for h, so we have h equals x tangent of 25 degrees. And on the other one we have, let's see, we're going to multiply times x plus 30. So we'll have, h equals x plus 30 times tangent of 18 degrees. Okay, so both of those are h. That means we can write them equal to each other. So we will say x tangent 25 degrees is equal to x plus 30 times tangent 18. So I'm going to distribute the x plus 30. I'm going to say x tangent 18 degrees plus 30 tangent 18 degrees. All right. Is it 30 or 50? 30, right? Yep. Okay, so we want to solve for x. We want to get the x's on the same side. This will be x times tangent of 25 degrees minus x tangent of 18 degrees equals 30 tangent of 18 degrees. Okay, factor out the x, so we have x times tangent of 25 degrees minus tangent of 18 degrees. Notice I just factored out the x equals 30 times tangent of 18 degrees. And then I'm going to divide by tangent 25 minus tangent 18 to finish solving for x. Okay, so divided by tangent 25 degrees minus tangent 18 degrees on both sides. All right, so that's x. X equals 30 tangent 18 divided by the difference tangent 25 degrees minus tangent 18 degrees. And then we can find an approximation. Okay, so x, we're looking for h, right? Oh, shoot. That's fine. We can find x and then find h. So x is approximately, let's see, 30 tangent 18 divided by tangent 25 minus tangent 18. And my calculator says 68.9, and I'll round to the 10th of a degree, to the 10th of, to the nearest 10th. All right, so we have x is about 68.9. Okay, so we want to find h. Remember, we can find h if we know x. H is x times tangent of 25. So h equals x is 68.9 times the tangent of 25 degrees. And this will be approximately now 68.9 times tangent of 25 degrees. So 25 degrees tangent times 68.9, and I get 32.1. 32.1 feet. All right, and then we're going to add the 5.5. Okay, so it's 32.1 feet plus 5.5 is 37.6 feet. Okay, that'll be the height of the fountain. All right, and we'll leave number B to do in class. It's very similar if you want to try it beforehand. All right, and that'll be the end of section 7.2.